3. Module 3 says 5 teams are to meet around a round table, and each team consists of 2 members and 1 leader. How many seating arrangements are possible if each team sits together with the leader of the team in the middle? So I am a person that I have to see what is going on. So I draw a table. I know it's not round, so let me make it better. This is a round table. The round table, all right? And you have how many teams? They said that there is 5 teams. There are 5 teams. 1 team, 2 team, 3 team, 4 team, 5 team. So there are 5 teams around the round table. Now, generally, to find the number of combinations around a round table, it's going to be equal to n minus 1 factorial. N minus 1 factorial. That's the formula for number of arrangements around the round table. All right, you have to remember that is number of arrangements. Around a round table. Number of arrangements around a round table is given by n minus 1 factorial. Now, in this case, it is 1, 2, 3, 4, 5. So it's going to be equal to 5 minus 1, which is 4 factorial. But when I finish it, multiplied by, we need to look at the different combinations now of how the teams are seated. The leader sits in the middle. We'll put the leader has to sit at the middle. Well, he doesn't have to, but he wants to. So the leader of each team sit in the middle. The leader here and the leader here. So what that means is that on the edges, one of the person can sit here. So maybe I can sit here or I can sit here. So there are 2 possibilities here. There are 2 possibilities for where this person can sit. This person can sit either here or here. So that's 2 possibilities. And it's times 2, times 2, times 2, times 2. So it's equal to 4 factorial times 2, times 2, times 2, times 2, times 2. That will account for all of the different teams. All right, so you put all of that in a calculator. And so that's going to be equal to 4 factorial times 2 times 2 times 2 times 2 times 2. 2 times 2 times 2 times 2 times 2 times 4. Getting 768. So just to write it pretty, I think you can write it as 4 factorial times 2 to the 5th power, just to make it easier. 768. So it's equal to 768 ways. So there are 768 ways this can be done. All right, nice and easy. So that's part I. Now let's look at part 2. Part 2 says, in an experiment, individuals were asked to color a shape by selecting from 2 available colors, red and blue. The individuals chose 1 color, 2 color, or no color. It says 80% of the individuals use colors and 600 use no colors. All right, so once they're telling me about colors, no colors, and stuff like that, I'm thinking of a Venn diagram. That's just how my brain works. I like the Venn diagram. You can never go wrong. Right? So I'm thinking of a Venn diagram here with colors, one color, two color, and whatever. And it is saying that one of the color is red, and one is blue. So maybe we can put red here and blue here, and then this would be the two colors. It says 20% of individual use no colors. Because if 80% use colors, 20% don't use no colors, and so 20% of the total amount of students, let's call the total amount of students X. So 20% of X is equal to 600. So if 20% of X is equal to 600, remember 20% is 1 over 5, so 1 over 5X is 600. And if 1 over 5X is 600, then X is 3000. So that means the total number of students is 3000. So this is 3000. That's the total number of students. Now, since this is 3000, then out here it's going to be 600. Out here is 600. And then it says that means that 2400 use colors. 2400 is in here. And it says now, okay, calculate the probability that, given that 40% of the individuals use red. So 40% of everybody use red. So 40% use red. So 40% of 3000, 40% of 3000 use red. And so I'm just writing down information given. And so 40% of 3000 is 1200. All right. So 40% of 3000 is 1200. So 1200 use red. This is the amount that use red. Now, what else they're telling us? They tell us 50% use blue. So blue is 50%. So blue is going to be 50% of 50% of the individuals use blue. So 50% of 3000 is equal to 1500. All right. And it says calculate the probability of those that use both colors. All right. So as you can see, you have 1200 in total use red. And so if you want to call the intersection n, it's going to be 1200 minus n. And then in here is n, and then over here is 1500 minus n. This would be what we have, all right? This is just what represents everything. You want the probability of both. Now, you can do this now just using this formula. The probability of red intersect blue is going to be equal to the probability of red plus the probability of blue minus the probability of red union blue. And that works out to be the probability of red, which is 0.5, plus the probability of blue, which is 0.4. Actually, add it around 0.4 plus 0.5 minus the probability of red union blue. And their union is 0.8. How do I know that? Because this together was 80%. All right. And so the probability of red intersect blue is equal to 0.1. So that's 10%. All right, so that is 10% use both colors. So if 10% of everybody use both colors, and this should be 10% of 3,000 is 300. So in here, so it should be 300. So if you want to write it, this intersection is 300. And then so over here is really 900. And so over here is really 1200. Now pre this, 900 plus 300 plus 1200 plus 600 is 3000. And 300 over 3000 is your 10%. So that's the answer. 10% use both colors. So this is a set representing everything. That satisfies part A and part B. So answer both our question already. So 3000, this was part B. This is the answer for part B. This is the answer for part A. Nice. Now go to matrices. It says A and B are two matrices. And it says determine the range of values for X for which A inverse exists.